engineering tutorial YouTube channel. Today we show experiment number 26. To obtain the performance characteristics of a reciprocating pump. Apparatus 1. A double-acting reciprocating pump with all the necessary components, i.e. suction and delivery pipes, no return valves, foot valves, etc. 2. An electric motor coupled to the pump shaft, wattmeter connected to the driving motor. 3. A vacuum gauge, or U-tube manometer, and a pressure gauge connected to the suction and delivery pipes respectively as near to the pump as possible. 4th, a discharge measurement unit, viz. And venturimeter with manometer, connected to the delivery pipe. Theory: L. The reciprocating pump is a positive displacement pump as it sucks and raises the liquid by actually displacing it with the piston plunger that executes a reciprocating motion in a closely fitting cylinder. The amount of liquids pumped is equal to the volume displaced by the piston. The total efficiency of a reciprocating pump is about 10 to 20% higher than a comparable centrifugal pump. The main parts of a reciprocating pump are 1. Cylinder 2, piston 3, suction valve 4, delivery valve 5, suction pipe 6th, delivery pipe 7th, crank and connecting rod mechanism operated by a power source, e.g. steam engine, internal combustion engine, or an electric motor. Working of a single-acting reciprocating pump, as shown in figure. 30. A single-acting reciprocating pump has one suction pipe and one delivery pipe. It is usually placed above the liquid level in the pump. When the crank rotates, the piston moves backward and forward inside the cylinder. The pump operates as follows. Let us suppose that initially the crank is at the inner dead center, IDC, and crank rotates in the clockwise direction. As the crank rotates, the piston moves towards right, and a vacuum is created on the left side of the piston. This vacuum causes suction valve to open, and consequently, the liquid is forced from the sump into the left side of the piston. When the crank is at the outer dead center, the suction stroke is completed, and the left side of the cylinder is full of liquid. When the crank further turns from ODC to IDC, the piston moves inward to the left and high pressure is built up in the cylinder. The delivery valve opens and the liquid is forced into the delivery pipe. The liquid is carried to the discharge tank through the delivery pipe. At the end of delivery stroke, the crank comes to the IDC and the piston is at the extreme left position. Working of a double-acting reciprocating pump. In a double-acting reciprocating pump, suction and delivery strokes occur simultaneously. When the crank rotates from IDC in the clockwise direction, a vacuum is created on the left side of piston, and the liquid is sucked in from the sump through valve S1. At the same time, the liquid on the right side of the piston is pressed, and a high pressure causes the delivery valve D2 to open, and the liquid is passed on to the discharge tank. This operation continues till the crank reaches ODC. With further rotation of the crank, the liquid is sucked in from the sump through the suction valve S2 and is delivered to the discharge tank through the delivery valve D1. When the crank reaches IDC, the piston is in the extreme left position. Thus, one cycle is completed, and as the crank further rotates, cycles are repeated. Because of continuous delivery strokes, a double-acting reciprocating pump gives more uniform discharge, as compared to a single-acting pump which pumps the liquid intermittently. To get a still more uniform feed, invariably a multi-cylinder arrangement having 2 or more cylinders is employed. Coefficient of discharge. In a reciprocating pump, the actual discharge, Q-act, is always slightly different from the theoretical discharge, QTH, due to following reasons. I. Leakage through the valves, glands, and piston packing. Y. Imperfect operation of the valves, suction and discharge. And I. Partial filling of cylinder by the fluid. Slip. The difference between the theoretical discharge and actual discharge is called the slip of the pump. That is, slip equals Qth. Cocked procedure 1. Note down the diameter D and stroke length L of the piston, wattmeter constant K, distances ZD and ZS of the pressure gauges from the pump axis. 2. Start the motor and open the delivery valve fully. 4th. Measure the discharge Q actual. Note down the pressure gauge readings PD and PS and also wattmeter reading X. 5. Measure the number of strokes occurring in a given time and hence obtain the speed of the piston in revolutions per minute. 6. Change the opening of the delivery valve. Repeat steps 3 to 6 for at least 10 different openings of the delivery valve. Precautions. 1. Do not run the pump with the delivery valve completely closed. 2. After each change in the valve opening, let the flow stabilize before taking readings.